Hello, everyone. We're going to get started in just a few minutes around 5 p.m. Thank you for being here.
One, two, 1, 2, 1, 2, 1, 2.
Hi, Fred.
Yeah, can you hear me?
Yes, we can hear you great. Thank you so much.
Perfect. All right.
We're gonna be starting in a couple more minutes, and we'll have Emma introduce both of you. Hello, I can see some people have logged in. Thank you so much for joining us this evening. You've logged in for connectivity with Nextivity and HKN, sponsored by Jacobs Talent Initiative. We'll be getting started in just a few minutes. We're just waiting for a few more people to log in, and we look forward to getting started.
All right, it is about 5 o'clock, so I think it's time to get started. So hello, everyone, and welcome to the first event under the newly renamed University Talent Program, the Jacobs Talent Initiative. Thank you for joining us for today's event put on in partnership with Ada Kappa Nu and participation from Nextivity. My name is Emma Jerez, and I'm the new Jacobs Talent Director for Tech San Diego. Before we jump in, I'd like to say a couple things about Tech San Diego and today's event. Tech San Diego is a nonprofit that works with small to mid-sized companies in the San Diego region. My role is to work with student organizations to plan events, such as this one, and inform students of opportunities in our local tech ecosystem, such as internships or job postings. We offer several resources on our website, such as a comprehensive regional tech directory, which indicates who is hiring in the region, and our Campus Connection newsletter, which highlights upcoming JTI events and promotions. I encourage you all to check out the resources on our site, located at techsandiego.org, and make sure you're subscribed to our Campus Connection newsletter so you do not miss out on important information. If you have any ideas for events or topics you would like featured on our podcast, please reach out to me at emma.hareas@techsd.org. For a few notes about today's event, I've worked closely with Vivian and members of HKN to facilitate an interactive environment which consists of a company presentation and product demonstration. After Vivian gives her remarks, I will welcome Mikhail to introduce himself and give his presentation. Once the presentation concludes, there will be a link to a breakout room in the chat, which is where we can all introduce ourselves with a brief icebreaker activity and watch Fred's product demo. Following the demonstration, we will open to Q&A and end with a virtual group photo. With that said, I welcome Vivian to say a few words about HKN.
Hi, everyone. My name is Vivian. I'm a third-year computer engineering student at UCSD studying computer engineering. And I'm also the HCAN ECE department chair. So just a little bit about HCAN. So we are the Honor Society and sister organization of IEEE, and we host a variety of technical professional events such as this one. So if you're interested in any of these types of events, feel free to check out our Facebook page and our website. And just for people that are just coming in, if you are an HCAN inductee, in order to get your HCAN inductee points, you'll have to sign in through our portal. So I will put the links again in the chat. Okay, so everyone should have seen another message in the chat. So if you're an HCAN inductee, please log in, go to the event, find this event on the calendar, and then press the blue sign in button at the top right corner. And once the event concludes, please put your full name and that you want to get checked off for points in the chat. And I'll take all those names and check you off. So, and also if anyone has difficulties signing in, please feel free to email me at vchiong@ucsd.edu and I could help you there. But this process is only for HCAN inductees. So if you're not an HCAN inductee and you're a guest, please sign in through the sign-in form at the bottom of the message that I just put in the chat. So that's just the link for all guests to sign in. And yeah, that's all I have. Thank you everyone for coming, and I hope you enjoy the event.
Thank you, Vivian. I'm very excited to introduce our guest from Nextivity this evening. Joining us today, we have Mikhail Lauder, who is the CTO and VP of Engineering, and Fred Hyam, who is the Director of ASIC Engineering. I welcome both of you to introduce yourselves.
Hi, I'm Mikhail. I'm the CTO. You wouldn't believe it because I forgot to unmute myself. So I'm the CTO here at Nextivity, and I'm looking forward to chatting with everyone today about our company and what we do, and showing you some of the technology. And I'm happy to be joined here by Fred Hyam, who's our VP for Engineering, and who's the main architect of our of the chips that we use inside of our products.
All right. Thank you. Well, now I invite you to give your presentation. The floor is yours.
All right. I'm going to can you just confirm that the presentation is sharing?
I can see it.
You are good to go.
All right. So it's awesome for us to be here today. You know, we're always happy to work with the local universities. We have a long history of working with UCSD as well. Every year we have, well, except maybe this year we didn't do it because of the COVID issues, but every year we have some interns here from UCSD, and it's always good to interact with them and show them around and hopefully teach them a little bit about what it takes to build a product. I'm going to talk more about the company, but I want to start off by saying that there's really a difference between creating technology and creating products, and there's an art to creating products that someone is going to take money out of their pocket and give it to you. Often we get really engrossed in the intellectual pursuits, solving the problems that we need to solve, and what does this algorithm do and how does this thing work and so on, that we sometimes lose touch of what it takes to actually make something that can be in a store and that said a person can be willing to take money out of his pocket that and give it to you for that product. So at Nextivity, we have a really good mix of being able to work on interesting intellectual problems, but also at the end of the day, we build products that get manufactured in a factory, they get put on a boat and ships to customers and get deployed in homes and businesses all across the world. So it's really a privilege to see everything and how the product is made. So the company was founded in 2006 and we launched our first product in 2009. All of our R&D is done here in our headquarters in San Diego. All of our engineering specifically is done here in San Diego, although our manufacturing is done overseas. And we have offices here in the US and then across the world, so the UK, Spain, Australia, Singapore. So, we're well presented. Today, we sell our products to more than 200 different mobile network operators across the world. Almost all of the top 20 network operators, the AT&Ts, Verizons, Orange, Telefonica, Telstra, all of these operators are customers of Nextivity, and they are our customers because they value the uniqueness and the innovation that we bring to our products. So, it's important to understand, I think, the DNA of a company, what makes a company unique, and what does a company value. And one of the key aspects that we value here at Nextivity is that each product that we build must be a unique product. We do not have any Me Too products, and we never intend to build a Me Too product. There are companies that are really good at that can squeeze the last dime out of the cost of a product, and they can make, they are great companies and they can make a good living doing this. That's just not the DNA that we have here at Nextivity. Our products generally command a premium market position. We want to be seen as the best product, and we put a lot of effort into every product that we do to establish that premium position in the market. Today, we have 33 issued US patents on various aspects of our products, and we have another 8 pending patents that are especially focused on some of the things that we are talking about today. 33 patents may not seem that much for a company, if you compare us with Qualcomm, but Qualcomm is, of course, a lot bigger than we are, and we tend to focus on key system-level patents that can block someone else from putting a specific feature into a product and into the market. And I think we've been very successful at doing that. So we definitely, as I said, we value innovation, and we try to capture that innovation in our patent portfolio. As I mentioned before, we are used by more than 200 carriers in 100 different countries, all the way from the largest countries in the world, the USA, China, Russia, Australia, to the smallest countries in the world. You wouldn't think about it, but we actually do great business in some small island countries like the Maldives, right? So our product portfolio spans a really broad range of different applications. Today, we're going to focus on one of those products called the QUATRA 4000. And we're going to talk a little bit about what goes on inside of as a system, what the QUATRA 4000 does. And then Fred is actually going to talk a little bit about the chip inside and what we do inside of the chip and how the chip was architected before we get to the demo later on. So the QUATRA 4000 has won a number of different awards for us, as innovative products, products supporting IoT, so Internet of Things, products that make it easy to provide coverage inside of buildings. So we're really happy with this product, and is it the way that the industry has adopted the product so far. The other part of our DNA is that our products must support a scalable market. I think it's, there's a big difference between building one product and having to build, a million of a product. The issues that you face in the factory, the issue that you face with, from a quality standpoint and from a management standpoint in terms of how you manage software releases and things like that, it's completely different. If whether you're building, say, a few products or one product that you're going to ship to many, many different countries. So we make our money by shipping as many products as we can, right? And that's how we scale our business. So in order to do that, we must make sure that our products are quick, are easy to install, are quick to deploy. And that thread of making it really easy to use our products, that's really been integrated into our into all of our products that we have developed. So there are a number of examples here shown on the screen here, and you can see some of these products that have shipped to places like Australia. So this is shipped to Telstra, product shipping to China Unicom. This is a Russian operator, Beeline, Vodafone. So there's Airtel is an Indian operator. So we've really, as I said, covered the globe with a number of different operators, and you said getting our technology out there. So if you look at all of the Cel-Fi products, what is the value proposition that we're really trying to bring to the market? So as I mentioned before, number one is best in performance. So if you take our product versus any other product that is in the market today, we have the biggest coverage footprint. So with the smallest amount of money, basically, you can cover the largest amount of area inside of building with cellular signals. So the goal of all of our products is the same. If you have a problem with cell phone coverage inside of your building, you need to resolve it in the most quickest, most cost-effective manner. Then you will look to one of the products in the Cel-Fi portfolio to provide you with that coverage inside of the building. And as I mentioned, right, so best in performance, that's the hallmark of all of the Cel-Fi products. By having the best performance, that allows us to have the best total product cost. So the widget that you buy from us, the physical product, we're never the cheapest product, but we look at the overall cost of solving the problem, right? We always try to keep the problem in mind and not just to get too focused on the product itself. So if you look at the cost to solve the problem, we are typically a market leader from a cost point of view. I mentioned that our goal is to ship as many products as possible and allow people to install these products in the shortest amount of time. So you need the easiest setup to be able to do that. The more you can incentivize people that are installing the product, the more installations that they can do in a year, the more money they make. The more money they make, the more they love you, and the more they love you, the more products they buy. So this investment in this ease of use is actually a big part of the investment that we make in our partners and then also in ourselves to make sure that we get the the return on investment that we want. Our products are also what's called network safe, which means that you can deploy these products in like an LTE network or a 5G network even, and make sure that you don't do any harm to the network. We've built our reputation over the last 10 plus years as a company that has the highest technology approach to solving the problem of of causing network related issues. And the fact that we are doing business with 200 network operators today, that really shows you how far we have come from having to convince people in the beginning that our technology is safe to where we are today. Our products are all intelligent, which means that they can listen to their environment and then basically reconfigure themselves in response to what they sense in the environment. And that feeds into our network safety guarantee that we can give to our customers and show them that with all of this intelligence that we have, there's never a chance that you can do any harm. So that gives you 100% peace of mind, no risk for the carrier, no risk for the customer, right? You can deploy these products wherever you need them. So if you look at the technology platform that we have, we are a vertically integrated company. We do everything, right? We start off by developing the chips that go into the product. And Fred's team, does that, and he leads the larger engineering team here as well, and he's focused, on the chipset as well. We write all of the embedded software that runs on the chip. We take that chip and we put it inside of a product. So we build, the PCB, and we just do all of the RF engineering and the RF design to implement the full product. Of course, we're a radio product, so we need antennas to be able to receive the signal and transmit the signal. We do all of the mechanical design for all of the housings, calculate thermal consumptions, look at how you should design the mechanicals to be, for example, like what's called NEMA 4 rated, so be able to be used outside or, be sprayed with water in the case of our public safety products. So all of these disciplines that are required to be able to build a product, we have them here in our San Diego facility. And then, as I mentioned before, right, we focus on making it really easy to use our products. And for that, we have a number of tools that we use, software tools, apps that are on the App Store. We have a cloud-based implementation of a remote monitoring and management system that I will show to you during the demo today as well. And we've actually, over the last 3 or 4 years, invested heavily on the app and the cloud side, and we continue to do that because we see that as a big differentiator of our product versus other products. There are many people that have cloud implementations. We focus on being enterprise grade, so there's a number of different standards that our cloud solution complies with. If we look specifically at our Cel-Fi QUATRA product, we have a few different variants of our QUATRA product. We have our QUATRA Red, which is what we call a public safety solution. So the two-way radios that firemen use, they must be able to work inside of a building, right? Clearly, if the fireman goes into the building and they have to go into the basement and there's a fire in the basement, their radios need to work there. And the QUATRA Red system provides them with that coverage. Our QUATRA 4000, this is our commercial cellular product, and the one that we sell in North America here. It improves the coverage for Verizon, AT&T, T-Mobile, and Sprint. Of course, T-Mobile and Sprint is now one. And the QUATRA 1000 is a smaller sort of version of the QUATRA 4000 product that we have. So how does it work? So the system has two parts to it. The first part is what we call our network unit. That's this guy here. And it basically connects to either to antennas or to small cells to use that as donor signal. So the signal that you want to have inside of your building, you feed that into the network unit. So he said you can either do that using antennas, or you can even have small cells that you can take the output from a small cell and feed that into the network unit. The network unit, you can see it's got 4 antenna inputs. So we have one for AT&T, one for Verizon, one for T-Mobile, one for Sprint. And each one connected to its own antenna so that we can optimize the signal that we get from each one of these operators. So we grab the signal, and then we basically do a bunch of signal processing on it using the chip that we've developed here, and that's the one that Fred will talk about in a few minutes. And then we send that signal over Ethernet, standard Ethernet cable to what we call our coverage unit. And then at the coverage unit, we turn the signal back into an RF signal, and that gets distributed with antennas inside of the building. So this is an example. So we have our network unit there, and then on each floor in this building, we've got a coverage unit. And then to every coverage unit, we connect a number of antennas to basically fill the building with the coverage that is required. I'm going to hand over to Fred here, and Fred's going to talk a little bit about our IntelliBoost chip, which is really forms the heart of our product.
All right. Good evening, everybody. So yeah, as Michiel mentioned, right, the heart of our product is our chip, right, that we call IntelliBoost. It's our 4th generation of ASIC, of chip that we have, and the one that basically we now use for all of our new products. So it's really what makes us really different from the competition, because that gives us the performance that Michiel was talking about before, like being able to cover a very large footprint in the building, right? Because we take the signal from the RF from the base station and we can take it to baseband and do a lot of DSP processing on it. And that's really what makes a big difference. I have another slide. The next slide will show you a little bit more what we do in terms of DSP processing. But so this is like a high-level block diagram of our chip. So you have the little green boxes are represent the IC, the RF, the radio frequency IC, which gets the signal from the base station, then connect directly to our chips with this which called digital interfaces, and then they go inside the chip. We do some DSP processing on it. I'll talk a little bit more about it on the next slide, and then go on the other side, and we go out on another RF and retransmit on the other side. So basically, we have the signal coming in from the base station. It goes through the chip. We do some DSP processing on it, and then we transmit back on the other side. So we can support different type of RF. We can do SISO, which is basically only one antenna, or we can do MIMO, meaning that we'll have diversity or two antennas coming in, so two different signals, and we can handle both of them. We have a number of peripheral as well that you can see on the top of the picture, like Ethernet MAC, so we can connect to the network. We have USBs. We have two USBs that we can use for different purposes, like logging or debugging or connecting to a computer or this kind of thing. And we also can connect to a coprocessor or an FPGA, which is the programmable chip. And we use that a lot to extend the feature of the chip, right? So for instance, on the QUATRA, on the QUATRA 4000 that Michiel was talking about just the previous slide, we have, for instance, an Ethernet cable that connects one side to the other, right? So we use actually this coprocessor to take the signal, put it on the cable, send it on the coverage unit on the other side, and then again we can go to another IntelliBoost chip and retransmit on the other side. So we have a lot of options with our chip, thanks to the fact that we can actually have coprocessor and add different functions. For instance, as well, we have a different version of it for our public safety product, which has different requirements. So it's still very open, and it gives us a lot of options. So I think that's mostly on this slide. So the next slide, I'm going to talk a little bit more here about the DSP processing part, right? So on the previous slide, like you saw, so we get the RF signal directly from the base station, and it comes to the chip in the form of a baseband digital signal. What we're going to do on that, we're going to use first a number of filtering. So we need to clean up the signal. We need maybe to do some rate change depending on the size of the channel or the bandwidth of the channel that we are looking at. So that's the first part, the filtering part. So we use different type of filter, like what we call IR filter or FIR filters. Then we hit this block in the middle that we call the echo canceller block. And this block is really what makes our product unique and give us the performance, right? This is what's going to keep the system stable, that's going to give us the possibility to have a lot of power on the transmit side. And the reason is because on a cell phone, a booster, or what it is, right? You take the signal on one side and you retransmit on the other side. So what you retransmit is going to basically loop back to the input, right? It's like an echo, what we call the echo path. So, and the problem is if you do that, if you amplify too much, the signal can become, the system can become unstable. So this echo block, as the main purpose of it, is to make sure that this echo signal that come back from the transmitter is reduced to a minimum as much as possible. And the more we can reduce it, the more we can actually, the more transmit power we can have on the output, and the bigger the footprint we can have. So it's a very, very important block, and that's really what makes our product unique. And there is a lot of complexity in this block. That's, if you would look at the chip area, that's a big part of the chip area that we have. So after the echo block, we again go through some different type of filtering, and we can re-upsample the signal if we need to, and then go to the RF again. So that's basically that was a DSP part. Now, in addition to the DSP part, we have obviously a software running, a lot of software running on the chip, and we have this what we call CPU subsystem here that includes 9 CPU cores. Okay, so we use 9 CPU cores for different functions. One of them is used for control. All the different main control setup and so on in the chip. We have one CPU that is dedicated to do LTE decoding, for instance. So when we get the LTE signal, we need able to decode it to some extent to get information about the base station and all the channels available and this kind of thing. And we have CPUs that the one I call here from A to F. That's 6 of them that can actually 5 of them, right? That can be used for that are actually used for AGC, for gain control. So a big part of keeping our system stable is to control the output gain of the system, right? How much power we can transmit. And we have software running on the CPUs to control that. So it's a very important part as well. And we have a what we call a COM CPU that is, the purpose is to do debugging, to connect to the USB, to Ethernet Max, to connect to the network, to the LAN, to the USB, to the PC, and so that's all this part. We have a DDR memory controller. Actually, we have a DDR memory that is stacked on top of our die. So it's actually a stacked die. And of course, we have a bunch of little peripheral inside the chip. We have like embedded memories. We have a number of peripheral like UARTs and serial interfaces and so on. So one thing about the CPUs is we actually have decided to use a core from OpenCore. Okay, it's OpenRISC 1200. It's actually a free and open source code, and it's a code collaboration. You can download it for free. Actually, many universities and maybe you guys at UCSD have been using it before. And we have also contributed to the effort. So what you can do is, which is great about it, is you can get the code. So it's Verilog code, which that's a language that we use to do chips. You have the source code, and you can make some change on it, for instance, to customize it to your application. You can add custom instructions. That's what we have done as well. So you can run faster your applications. So it's very flexible, and it actually works great. We have been using this OpenRISC for the last 3 IntelliBoost chips that we have done, and we're still very happy about it. And it's, the good thing about it, it's free, and it's open. Everybody can use it. So it's really nice piece. So last slide, just a little bit of numbers. So this is actually the picture on the right here is a floor plan, the layout, a little bit of our chip. So you can see, the big coral, look like clouds, are more gates. Okay, so that's logic gates that we use. The square, like the memory part of it. And you can see, for instance, the USB on the top left corner, that's the USB 5 that can connect directly to the USB connectors. We have a number of IP like PLL, like analog to digital converters, and all around the chips. That's the little line that you see are the IOs that connect to the pins. So in numbers, basically what we have, it's a chip that has 8 million logic gates. We have like 20 million memory bits. We have a number of like third-party IPs that I mentioned before, like an Ethernet MAC. We have USB 2.0. We have an ADC, we have PLL. I mentioned before we have stacked die, so that's a main chip that you see here. But on top of this one, we have a DDR memory that is stacked on it, and all that is packaged into this 596 IO packaging that is like 23 by 23 millimeters. So that's pretty much conclude what I wanted to say about this chip. That's again the very important part of our product.
All right, thanks, Fred. I think that was our presentation.
All right, awesome. Well, thank you, Michiel and Fred. That was excellent. So to transition into the next part of our event, I invite all of you to follow the link in the chat where we will join a breakout room. This gives us the opportunity to interact with each other in a more intimate setting. So see you all there shortly. All right, well, the link was just sent in the chat. So there will be someone here in the webinar in case there are any technical issues transitioning to the breakout room. But at this point, I'm going to start making my way over there.
Is it, so which link is it? Is it the Sarah Spivak or what is this?
Yeah, follow the link that I sent.
Okay, I'll go to meeting. Okay.
Please, thank you. Please and thank you. Emma is the host, so she has to log off before you guys can get into the room. Thank you so much for taking time to talk about your products.
Our pleasure. If you want us to follow you to the breakout room, you're gonna have to tell me how to do it again.
Yeah.
Okay, so so I sent you guys a link. If you copy the link and paste it
Or in the chat?
In the chat.
So is it like the global goToMeeting.com/join/4163?
416-732-709.
Okay, so that goes directly to a web browser, I guess.
Yes, correct.
All right. Okay, open link. Okay, I'm already in the session.
Awesome.
Thank you all.
Am I there? Am I there in the break room?
No. You gotta copy.
This one?
Yeah, so copy and paste here. I'm gonna send it to you again. No, you're gonna have to leave this chat to go to the other one.
I'll give everyone a few minutes to situate over here, and then we can start the next part of the event.
Okay, so I have to read this.
I sent it to you again. You should be able to just follow the link this time.
Okay, so I close the other one. No.
I see Michiel. Michiel is in the room.
I follow the link, but so when I go to the link, okay,
If
I open the link.
We can make it more interactive so we can see each other's faces if you're able to.
Go to meeting. Session is already running.
Yeah, so you have to leave this one to go to the other one. So if you can copy this, open a second window. copy and click this link, and then you should be able to close out of this.
Okay.
Before you hit enter.
Oh, before it.
So copy it and then close out of this, paste into your browser, and then hit enter.
Okay,
No worries.
All right. Let's see what.
This conference is no longer being recorded. This conference will now be recorded.
All right. Well, I think that's about everyone here. So welcome back. Nice to see most of you here. All right. So before we start the product demonstration, I invite you all to share your name, major, the field you're interested in, or the first place you'd like to travel once the pandemic ends. Is there anyone that would like to start?
Do you see? Do you see the link that oh, perfect. Okay. Oh.
And I believe the one place I would like to go after the pandemic ends is probably Japan, but that's kind of a cheating answer because I've already wanted to go to Japan for a while now.
Definitely, yeah. I mean, it looks beautiful. It's one of the places I'd like to travel to.
Yeah.
Is there anyone else that feels like sharing? Well, I know one place that I'd like to travel to is Greece. I've heard it's beautiful. I've seen lots of photos online, and it's definitely on my list of places to go. Has anyone been to Greece before or Japan?
It doesn't sound like it.
Yeah, I guess not.
People able